It is 4 in the morning, July 19th, 2024, and across the planet, without warning, screens are turning blue. Airport departure boards in Melbourne, self-checkout kiosks in London, patient monitoring dashboards at hospitals across the United States, desktop after desktop after desktop, each one freezing, crashing, and displaying the same cryptic error message that Windows users have dreaded for 30 years, the blue screen of death. Within minutes, it is not dozens of machines, it's thousands, then 10 of thousands, and then millions. Flights are grounded, 911 centers lose their dispatch system, Sky News, a 24-hour news network in the United Kingdom, goes off the air entirely, unable to report on the very story consuming the world. By the way, this one was for good. Banks can't process transactions. Hospitals can't pull up the patient records. Supermarkets can't ring up groceries. And the cause of all of it? A single file, 42 kilobytes, smaller than the photo on your driver's license, pushed to 8.5 million computers simultaneously by a cybersecurity company whose entire job was to protect those computers. The fix will take 5 minutes per machine, but there are 8.5 million machines, and every one of them needs a human being to physically walk up to it, reboot it, and delete that file by hand. To understand what happened on July 19th, you first need to understand CrowdStrike and why by the summer of 2024, it had become one of the most important companies most people had never heard of. CrowdStrike was founded in 2011 by George and Dimitri. Their pitch was straightforward. Traditional antivirus software was dead. The old model, download a list of known viruses, scan your files, hope for the best, could not keep up with the modern attackers. George and Dimitri wanted to build something different. A lightweight agent that would live on your computer, watch everything happen in real time, and stream that data to the cloud where machine learning could identify threats that no static virus list would ever catch. They called the platform Falcon, and it worked amazingly. CrowdStrike became a major name in cybersecurity circle in 2016, when it was the firm that identified Russian military hackers inside the Democratic National Committee's network. The company went public in 2019 with a blockbuster IPO. The stock soared. By mid-2024, CrowdStrike protected more than 29,000 organizations worldwide, including 298 of the Fortune 500. Its market capitalization exceeded $74 billion. The Falcon sensor, that small piece of software installed on your protected machine, had become an invisible guardian. It ran silently on millions of Windows computers, at banks, in hospitals, at airlines, on retail terminals. Most of the people using those machines had no idea it was there. George, meanwhile, had become one of the most prominent CEOs in cybersecurity. Confident, media savvy, a regular on CNBC. But there's a detail in his biography that you should file away. Before founding CrowdStrike, George Kurtz had been a chief technology officer at another cybersecurity company, a company called McAfee. So how does the Falcon sensor actually work? And why does it need to be so deeply embedded in your computer? Your operating system has layers. The top layer is where your everyday application runs. Your browser, your email, your spreadsheet. This is called user mode. If something goes wrong up here, the application crashes, you lose some unsaved work, and you move on. The system stays standing. But beneath that is the kernel, the core of the operating system. This is where Windows manages memory, communicates with hardware, and orchestrates everything else. Softwares that run here has total access to the machine. And if something crashes at this level, Windows can't just close a program and carry on. The whole system has to go down. CrowdStrike's Falcon sensor runs in the kernel at ring 0, the deepest, most privileged layer of access. And it has to. To catch sophisticated attackers, it needs to see every process, every file operation, every network connection. You can't do that from the surface. Now, Falcon receives two kinds of updates. The first is the sensor update, traditional software patches that go through full quality assurance, Customers control the timing. The second kind is what CrowdStrike call rapid response content. Tiny configuration files called channel files that tell the sensor what new threats to watch for. These get pushed frequently, sometimes several times a day. And because they are classified as data, not code, they go through a lighter, faster validation pipeline. Think of it this way. A sensor update is like replacing a security guard. A channel file is like handing the guard an updated watch list. You wouldn't retain the whole guard for every new suspect. You just hand them a new photo. But what happens if the photo is corrupted? Every modern operating system divides software into two tiers. User mode, where your application lives, and kernel mode, where the operating system's code runs. Here's the simplest way to understand the difference. User mode is the passenger cabin of an airplane. Kernel mode is the cockpit. If a passenger has a medical emergency, it's serious, but the plane keeps flying. The crew manages it. Other passengers are unaffected. The flight lands safely. But if the pilot has a medical emergency, if something goes critically wrong in the cockpit, the entire aircraft is in danger. CrowdStrike's Falcon sensor doesn't sit in the passenger cabin. It sits in the cockpit. It runs at the same privilege level as Windows itself. And that means if Falcon crashes, it doesn't just close a window on your screen, it crashes Windows, the whole machine, every time, instantly. And most security tools work this way. They need cockpit access to do their job, which means every security vendor with kernel level access is, in effect, a co-pilot on every machine it's installed on. On July 19th, the co-pilot had a seizure at the controls. By mid-2024, the cybersecurity industry was locked in a permanent escalation. Ransomware attacks were surging globally. Nation-state hackers were targeting hospitals, power grids, and government agencies. AI-powered phishing was making attacks harder to detect than ever. Companies were pouring a record budget into endpoint protection, and CrowdStrike was the product that analysts recommended the most. If you were a chief information security officer at a major corporation, CrowdStrike's Falcon wasn't a luxury, it was a standard of care. Nobody was questioning whether the tool that protected everything might itself become the threat. But someone should have been, because this story had already happened once. On April 21st, 2010, a cybersecurity company called McAfee pushed a routine antivirus signature update to its customers. The update was called DAT 5958. It contained a defect. It misidentified a critical Windows system file as a virus and quarantined it. Machines around the world crashed and entered boot loops. Each one needed manual repair. The chief technology officer of McAfee at the time was a man named George Kurtz. Kurtz left McAfee shortly after. He founded CrowdStrike with an explicit mission to build better, smarter, more reliable endpoint security. For 14 years, he succeeded, and then came July 19th. July 19th, 2024, 4:09 am, Coordinated Universal Time. In CrowdStrike's content deployment infrastructure, a new channel file is released. It's called channel file 291, and its job is to add a new detection rule. Logic designed to spot a technique that advanced attackers use called named pipe abuse. Its real threat, this is a legitimate update. The file is small, 42 kilobytes. Its internal structure is built on what CrowdStrike calls template type 21, a predefined format that tells sensor's content interpreter how to read the data. Template type 21 expects 20 input field and 20 parameters for the sensor to evaluate. But this file contains 21 field, one more. This should have been caught. CrowdStrike has an automated tool, the content validator, that's supposed to check every channel file before it ships, confirm the structure matches the template, and approve or reject the file. On this morning, the validator examines channel file 291 and gives it a green light because the validator itself has a bug. It's not checking the field count correctly. The safety net has a hole and nobody knows it's there. The file enters CrowdStrike's content distribution network, and here's where a software bug becomes a global catastrophe. CrowdStrike's system pushes rapid response content to 100% of connected endpoints simultaneously. There is no canary group, no 1% test batch, no staged rollout where you send it to a small sample, watch for problems, and then expand. No waiting period, nothing. One push, every connected Windows machine running Falcon everywhere on Earth, all at once. Within seconds, the file is propagating to sensors in Sydney, Singapore, Mumbai, Dubai, London, Sao Paulo, New York. CrowdStrike's distribution network is fast. It's designed to be fast. Because when a real threat emerges, speed saves lives. On every machine that receives the file, the Falcon sensor's content interpreter begins reading. File 1, fine. File 2, fine. File 3, through 20, all fine. Then it reaches for field 21. The template only allocates memory for 20 fields. The 21st read goes past the end of the buffer into memory that doesn't belong to the process. Engineers call this an out-of-bound memory read. And because this code is executing in the kernel, in the cockpit, Windows doesn't shrug it off. Windows can't shrug it off. The machine blue screens instantly. Then it restarts, loads the same driver, reads the same cached file, crashes again and again and again. It's 2:09 in the afternoon in Sydney, Friday, the middle of the workday, and all at once, screens across Australia starts going blue. At Melbourne Airport, the flight information display go dark. At Woolworths supermarkets, self-checkout terminals lock up. At corporate offices across the country, IT help desks are suddenly drowning. One machine is down, then 10, then 100, then every Windows machine on the network. Within minutes, Australian IT administrators are doing what they always do in a crisis. Going to Reddit. Posts starts flooding into our system admin. Is anyone else seeing CrowdStrike's blue screen? Every machine in our org just went down. This is not a drill. The replies confirm the worst. It is not isolated. It's not one company. It's not one city. Every organization running CrowdStrike's Falcon on Windows is experiencing the same crash, the same blue screen, the same boot loop. CrowdStrike's support channel are overwhelmed. Their status page is slow to update. For the first 30-40 minutes, the only reliable source of information is system administrators sharing what they are seeing with each other in real time on social media. At CrowdStrike's headquarters in Austin, Texas, it's 4:30 in the morning. Engineers are being woken up. War rooms are being assembled. The pattern is unmistakable. Something in the latest channel file is crashing the sensor. They need to find it, confirm it, and revert it. By 5 a.m. UTC, 51 minutes after the push, internal teams have identified channel file 291 as the cause. And the scope of the problem is becoming terrifyingly clear. Now think about this for a second. It's not yet dawn in Europe. Most of America is asleep. And CrowdStrike has already pushed the update to every connected Windows machine on Earth. The wave of destruction follows the sun. As the business day begins in India, major IT services firms discover thousands of their managed servers are in boot loops. In Japan, retailers lose their point-of-sale systems. Across the Middle East, airlines operations stutter. Then Europe wakes up. In the United Kingdom, Sky News, one of the country's most watched 24-hour news channel, goes completely off the air. There's something almost poetic in it. A news network unable to report the biggest technology story of the year because its own technology has crashed. The National Health Service reports a major IT disruption. GP surgeries across the country can't access patient records. Some emergency departments start reverting to paper, handwritten notes, manual tracking. Airports go dark across the continent. Heathrow, Gatwick, Berlin, Frankfurt, departure boards shows nothing, or worse, they display the blue screen of death, photographed by travelers and shared millions of times on the social media. At 5:27 UTC, 78 minutes after the initial push, CrowdStrike reverts the channel file. They push the corrected version. Any machine that hasn't yet received the bad update will now receive the fix instead. But here's the problem. The problem that turns a 78-minute mistake into a multi-billion-dollar, multi-day catastrophe. The 8.5 million machines that already crashed, they are in boot loops. They can't start Windows. They can't connect to internet. They can't reach CrowdStrike's cloud. They cannot receive the fix. Every single one needs a human being to intervene physically in person. CrowdStrike stopped the bleeding in 78 minutes, but the patient was already on the floor. And this is what engineers call the what if moment. What if CrowdStrike had deployed this file to just 1% of endpoints first, a canary group of roughly 85,000 machines? The crash would have been detected within minutes, the rollout would have been halted, and other 99% would never have received the file. Instead of 8.5 million machines down worldwide, it might have been 85,000 only. A serious incident, absolutely, but a civilization scale event. That one decision to push to everyone all at once with no test group is the difference between a bad day and the worst IT outage in the history. When Windows encounters a critical error in the kernel, it doesn't try to limp along. It can't. The damage could be catastrophic. So it does the only safe thing. It halts everything, displays the blue screen of death, and restarts. Normally, the restart clears the problem. But in this case, the drivers that caused the crash, CrowdStrike's csagent.sys, loads automatically during boot. Every time, and when it loads, it reads channel file 291, which is cached on the local hard drive. Same corrupted file, same crash, same blue screen, same restart, an infinite loop with no way out. The fix is simple. Boot the machine into safe mode, a stripped down version of Windows that skips most drivers. Navigate to CrowdStrike's folder, delete the bad file, and it takes almost around 5 minutes. But there's a catch, a devastating one. Many enterprise machines uses BitLocker, Microsoft's full disk encryption. To access the drive in safe mode, you need a 48-character recovery key. Most organizations store those keys on a central server, a server running on Windows, protected by CrowdStrike, a server that is also in a boot loop. You need the key to fix the machine. The machine that stores the key is also broken. 2 locked boxes, each containing the key to the other. The United States comes online at around 10 UTC. It's 6 in the morning on the East Coast, and the country wakes up into chaos. Delta, United, American, Frontier, every major carrier running CrowdStrike on Windows is hit. But Delta Airlines is hit the hardest. Delta's operation center in Atlanta, the nerve center that tracks every aircraft, every crew member, every gate assignment, is heavily dependent on Windows system protected by Falcon. When those systems go down, Delta doesn't just lose some screen. It loses the ability to know where its planes are, where its crew are, and who is supposed to be on which flight. American and United recover within a day or two. Their IT infrastructure had more diversity, more layers of redundancy, but Delta will take around 5 days. The airline cancels more than 7,000 flights. 1.3 million passengers are stranded. Atlanta's Hartsfield-Jackson, the world's busiest airport, becomes a sea of people sleeping on terminal floors. Meanwhile, 911 centers in multiple states reports degraded services. The Social Security Administration closes its offices nationwide. And office buildings around the world, the real heroes of this story, are doing the grueling work. System administrators driving into remote offices, booting machines one by one into safe mode, hunting for BitLocker keys, deleting one file, rebooting, moving to the next machine. One system administrator posted on Reddit. One of the system administrators posted this on Reddit, and this code became iconic. I have seen thousands endpoint down right now. My team is 4 people. You do the math. Here's the math. 5 minutes per machine times 8.5 million machines equals to roughly 708,000 person hours. That's 354 people working 24 hours a day, 7 days a week for an entire week. There's no shortcut, there's no automation. There's only human beings walking up to the machines one at a time. At approximately 10:45 UTC, CrowdStrike's CEO George Kurtz posts on X. His statement reads, CrowdStrike is actively working with customers impacted by a defect found in a single content update for Windows hosts. This is not a security incident or cyber attack. The statement is technically accurate. It is also, in tone, precisely wrong. The word sorry does not appear. The world is on fire, and the CEO's first public message reads like a press release. The internet notices this immediately. The financial reckoning is staggering. Insurance analytics firm Parametrics estimates $5.4 billion in direct losses to US Fortune 500 companies alone. The broader global impact, including small businesses, indirect costs, and organizations outside the United States, may exceed $10 to $15 billion. CrowdStrike's stock drops 32% in the weeks that follow. Roughly $25 billion in market capitalization gone. Shareholders' class action lawsuits are filed, alleging the company made misleading statement about its software testing processes. And then there's a gesture that will live in crisis management infamy. As a goodwill measure, CrowdStrike sends $10 Uber Eats gift card to affected partners. Some recipients discover the code doesn't even work. Uber's own fraud detection system flags the mass distribution and cancel the vouchers. $10 million in damages and a $10 gift card. The memes write themselves. The loudest voice belongs to Ed Bastian, the CEO of Delta Airlines. Delta's recovery has been the most painful and the most public. Bastian goes on CNBC and declares, if you are going to have priority access to Microsoft's operating system and a bug gets in, the consequences are catastrophic. And that's what we experienced. Delta hires David Boies, one of America's most prominent litigators, and sues for more than $500 million. CrowdStrike fires back with a countersuit. They argue their contract caps liability at single-digit millions. They allege Delta refused offers of on-site engineering assistance. They claim Delta's own legacy IT infrastructure contributed to the airline's uniquely slow recovery. The legal battle will drag on, but it raises a fundamental question. When a software vendor's product breaks the world, who actually pays? September 24th, 2024, the United States Capitol. Adam Meyers, CrowdStrike's senior VP of Counter-Adversary Operations, takes his seat before the House Homeland Security Subcommittee on Cybersecurity and Infrastructure Protection. He is the highest-ranking CrowdStrike official to appear in person. CEO George Kurtz has submitted written testimony, but he does not show up. Committee members from both parties note the empty chairs. Meyers opens with an apology. On behalf of everyone at CrowdStrike, I want to apologize. We are deeply sorry. This happened and we are determined to prevent it from happening again. The committee presses him. Why was there no staged rollout? Why does the software run in kernel? Was the content validator known to be broken? How can customers trust that this won't reoccur? Mayer outlines what CrowdStrike has changed. Runtime boundary checks in content interpreter, enhanced validation with field count verification and fuzz testing, stage canary development for all content updates, customer controls to delay or approve updates, and independent third-party security code review. These are real improvements, but the hearing surfaces a question larger than any single company's remediation plan. Should any single vendor's automatic update mechanism have the power to simultaneously crash millions of machines running hospitals, airlines, banks, and emergency services? Is that a sane architecture for a civilization that depends on computers for everything? Microsoft, for its part, hosts a Windows Endpoint Security Ecosystem Summit the same month, inviting CrowdStrike, SentinelOne, and other vendors to discuss moving security tools out of kernel entirely. Apple had already done this on Mac OS in 2019, requiring third-party security extensions to operate in user mode. Microsoft argues Windows should follow suit, but points out that European Union antitrust regulations dating back to a 2019 agreement require Microsoft to give third-party vendors kernel-level access. The irony is layered. Regulations designed to promote competition may have made the entire ecosystem more fragile. And so we arrive at the irony that binds this entire story together. In 2010, George Kurtz was the chief technology officer at McAfee when a faulty antivirus signature update crashed Windows XP machines around the world. Boot loops, manual recovery, machine by machine, the industry called it a wake-up call. Kurtz left McAfee he founded CrowdStrike. He built it to be better, smarter smarter architecture, cloud native intelligence, faster response, and for 14 years it was better. CrowdStrike became the most trusted name in endpoint security. Then on July 19th, 2024, CrowdStrike's own content update system produced almost exactly the same failure. Faulty detection content pushed globally without staging, kernel level crashes, boot loops, manual recovery. The same pattern 14 years apart, the same person at the helm of both the companies. This isn't a story about a man's failure. George Kurtz didn't personally write channel file 291. He didn't break the content validator. The failures are systematic, organizational, architectural, procedural. But his career is a mirror for the industry itself. An industry that built a world where a single company's single file pushed to millions of machines with no staging could bring down airlines, hospitals, banks, and emergency services simultaneously. CrowdStrike published its root cause analysis on August 6th. The technical fixes are real, staged deployments, better validation, customer controls. The question is whether the industry will remember this time, or whether 14 years from now we will be telling the same story again with different names, a bigger blast radius, and the same lesson nobody learned. Here's the impact scorecard of CrowdStrike's outage of July 19th, 2024. Duration of active disruption, approximately 18 hours for most organizations, 5+ days for Delta Airlines. Machines affected, 8.5 million Windows endpoints. People directly impacted, an estimated 300 to 500 million worldwide. Flights cancelled, more than 10,000 globally, 7,000 by Delta alone. Estimated financial cost, $10 to $15 billion globally. CrowdStrike's market capitalization lost, approximately $25 billion. Root cause, software bug compounded by process failure and architectural flaw. Time from deployment to identification and revert, 78 minutes. Time to fix one machine, approximately 5 minutes. Time to fix all machines, days to weeks. Could this have been prevented? Yes. A canary deployment pushing to 1% of the machines first would have contained the damage to roughly 85,000 endpoints. A working content validator would have stopped the file from shipping entirely. Has this happened before? Yes. McAfee, April 2010, DAT 5958, nearly identical failure pattern. The same CEO was involved in both the incidents. Severity, critical. Global scale, multi-sector, multi-day recovery.